this video, we'll try to compute improper integrals involving vertical asymptotes. So suppose I want to compute this integral. So the integral from 0 to 1 of 1 over square root of x dx. So if you notice, this function, 1 over square root of x, is actually undefined at one of the endpoints, so at x equals 0. Right, so visually, what's happening is the following. So this is my function, 1 over square root of x, and then in the interval from 0 to 1, so at x equals 0, there's a vertical asymptote. Right, so there's a vertical asymptote here. And so as the integral represents the area of a region, this region extends to infinity vertically. So I'm trying to compute the area of this infinite region here. So we'll try to make a sense of this, similar to before, by changing it to a limit. So what I do is, instead of this interval with this infinite region, I cut it off at a point near 0, so at a, and then I let a approach 0 from the right. So what I do is I approximate the area with the finite region here, and then I slowly let the finite region become an infinite region. Okay, so I have the integral from a to 1 of 1 over square root of x dx, and then I take the limit as a goes to 0. But it's approaching 0 from the right. So I make a note of that. Okay, so now I do the same thing as before. I first compute the integral, and then whatever I get, I use to compute the limit. Okay, so the antiderivative. So actually, let me rewrite the integral first. So this can be written as x to the minus 1/2. Okay, so the antiderivative is x to the 1/2 over 1/2 from a to 1, and then the limit as a goes to 0 from the right. Okay, so now plug it in. So at 1, when x equals 1, this is 1, and then this 1/2 becomes a 2. And then at a, so again I bring the 2 up, so that becomes square root of a. And then as a goes to 0, this goes to 0. And so the value of the integral is equal to 2. So again, even though the region extends to infinity vertically, this actually has a finite area. Okay, so let's summarize the different kinds of vertical asymptotes you can have, and how to set up the corresponding improper integral. Okay, so the first kind is the kind that we just did in the above example. So suppose x equals a is a vertical asymptote, and my function is to the right of it. And I want to compute the area of the region in between a and b. So the improper integral will be the integral from a to b, f of x dx. Again, the vertical asymptote is at x equals a. Right, so one of the endpoints, the function will be undefined. So what we do is we cut off the interval near it, and then we let C approach the asymptote. So we integrate from C to B, f of x dx, and then we take the limit C goes to A from the right. The second kind of vertical asymptote is when the vertical asymptote is to the right of the function. So suppose the vertical asymptote is at x equals b. Say this is my function here, and again I'm interested in the area between a and b, right? So then it still extends vertically to infinity. So the integral from a to b, f of x dx. So in this case, vertical asymptote is at x equals b, so at the top endpoint. So this time, again, mark off a point near b, and then let C approach b from the left. So we integrate from a to c first of f of x dx, and then we take the limit as c goes to b from the left. The final kind of vertical asymptote so suppose now the vertical asymptote is in the middle of where you want to integrate. So again, the region that you want to compute the area of, there's a vertical asymptote in the middle. So here you have a vertical asymptote at x equals p. P is in the middle of where you want to integrate. So the way we do it is we integrate from a to b, f of x dx. So basically you just split it up into two integrals, to the left and to the right. So you so the first integrate, well, you integrate from a to p, f of x dx. So this is going to be improper integral of type 2, and then you integrate from p to b, f of x dx, and then this will be an improper integral of type 1. And then this will be type 1 improper integral. And so these are the three types of improper integrals where you have a vertical asymptote.